we're given the matrix A from over some number field F. The size is m times n, and also matrix B, same number field, the size is n times n. And if this matrix is invertible, the matrix where it's made up of m times m identity matrix minus A times B, then we want to show that this matrix, identity matrix n times n minus BA, also invertible. And that inverse is In plus B times the inverse of In minus AB times matrix A. First, we can easily verify it. Then I'm going to show you the motivation. It's like, where on earth does this result come from? Right? First, let's verify. So all we have to show is that this times that equals the identity matrix. Let's see if that's the case. In minus BA multiplied by In plus B times inverse of In minus AB times A. Obviously, we distribute this matrix onto this matrix and that matrix. Right? And always keep in mind, keep the order, because matrix multiplication is not commutative. Right? Always resist the temptation of switching the orders. So In times In plus In times B times inverse of In minus AB times A. Alright, then we're going to distribute this matrix onto this and that. Minus BA, alright, keep the order. Right, BA times In. We minus all same order. BA go first, then times B times inverse of In minus AB times A. Yeah. So obviously In still identity matrix. And of course, is this legal? Right? In times B. Right? B, what's the size of B? Bn times m, right? As long as the row of this is equal to the column of that, right? N, right? So this is perfectly legal. Still B plus B times inverse of In minus AB times A. And also A times identity matrix, right? Well, what's the number of columns of A? N, right? So perfectly equal. Minus BA. And so B times A times B times A. Right. Copy this down. BAB In minus AB times A. That is equal to In. Let's copy down minus BA first. Then we're going to see this term and this term. Can we factor out? Right? Perhaps we can factor out B from the left-hand side. Right? Keep the order. And factor out A from the right-hand side. Also the same order. Right? So that is equal to B times. And can we also perhaps factor out this inverse? Because that's also their common factor. Right? Perhaps this inverse also, let's put it on the right hand side. Right? Then we can have but notice that if we let's say if we first put A on the right hand side, factor out. Suppose if we also factor out the inverse, what's going to happen? Right? In times minus AB. Right? And also factor out B on the left-hand side. So perhaps we're only left with just, we have nothing left on this term, right? This factor out, B is factor out. We're only left with 1, but the version of 1 in matrix is identity matrix, of course, because we cannot just simply write number 1 here, right? So what's its matrix version of 1 in this case? What's the size? I'm thinking of B. What's the size of B? N times M. So I want to make sure that the 1 matrix version of 1 sits on the right-hand side of B, right? So the size of the identity matrix has to be M times M, right? So after I factor out this and that, I'm only left with just A times B, right? Minus A times B. Right, so left-hand side B, right-hand side inverse times A, right? The common factor. Inside this bracket, I have their difference, right? So IM minus AB, IM minus AB inverse, right? So that's how we just cancel those ones out, right? So that is equal IN minus BA. So this and that. So what's the size of this identity matrix after I cancel them out? Right, notice what's the number of row? What number of rows of it? Right. M. Right. So size of A times B is also M times M, right? M by M, M by M, right? Together, M by M, right? Right? Of course, inverse also M by M. So in the end, we have identity matrix of I M by M, right? So B times identity matrix of M by M is illegal. B is N times M, right? M also M, perfectly legal, right? B times A in the end. So they just cancel out. So really, so what's the motivation behind this result, right? It just didn't just fall from the sky, right? Out of nowhere. But motivation. And so the following motivation is provided by Holmos. So using number instead of matrix, right, first we notice that if we use number 1, run 1 minus lowercase b times a, right? So it's inverse, right? 1 minus ba. Obviously, the formula for the infinite geometric sequence, geometric series, where the common ratio is b times a. Right, first term is 1. ba plus ba squared all the way. Right? So then we just copy down 1. Factor out b. Right? Also factor out a. And put a on the right-hand side, b on the left-hand side. We're left with 1 plus b times a plus b times a squared all the way. All right, so now that is equal to 1 plus b times, here is also infinite geometric sequence where common ratio is b times a, but we can also write it as a times b, right? A times b squared, same thing. So 1 over 1 minus a times b and times a, right? So put into matrix version, right? Its inverse should be equal to In plus matrix B times the inverse of In minus matrix A times B, right? Times matrix A. So that's where the In minus IM